Hey, what's up? It's Estrada here. Our learning target says I can explore the relationship between sides, area, and perimeter of similar triangles. Let's get to it. Example 1 says the base of an isosceles triangle is 5 and its perimeter is 11. The base of a similar isosceles triangle is 10. What is the perimeter of the larger triangle? So this is the kind of question where students be like, this is hard. It's not. And the reason why students would say this is impossible or hard is because there are no pictures. Students tend to like pictures. So if you like pictures so much, draw them yourself. And that's what I will do because I'm also a fan of pictures. We have an isosceles triangle with a base of 5. And we are told that the perimeter of this isosceles triangle is 11. So I'm going to write P equals 11 for it. Now remember what perimeter means. Perimeter means that all the sides add up to 11. So one of the sides is 5. And if the perimeter is 11, that means that these sides should be 3 and 3. How did I get 3 and 3? Well, these two sides have to be equal because the triangle is isosceles. Isosceles triangles have two equal sides. So they have to be equal, and then together with 5, they have to add up to 11. So it's 3 and 3. Then we also have another isosceles triangle that's going to be bigger. And I know it's bigger because the base is 10. It's got a bigger base than this one. And we are asked to find the perimeter of this one. So I'm going to write P equals question mark. Well, for us to find the perimeter, we need to know what this side and this side measure. Well, let's look at the relationship between the two triangles. The base is 5 here. The base is 10 here. And that tells me that this bigger triangle is basically a dilation with a scale factor of 2 of the smaller triangle. In other words, 5 multiplied by 2 is what gives me 10. So that means these two sides have to be 6 and 6 because 3 times 2 gives you 6. So 3 times 2 gives you 6, 3 times 2 gives you 6. So they both have to be 6 and 6. If you don't like doing it that way, if you think that's too confusing, you could label the sides x and x, and then you can just do a proportion. You can do 3 over 5 equals x over 10. You can do it that way. But either way, you're going to get 6 and 6. 6 and 6. Which means the perimeter is going to be 6 plus 6 plus 10, which will be 22. So the perimeter is 22. Let's write that inside the triangle. P is 22. Okay, now, little factoid. The perimeters of two similar figures are proportional with the sides. This is not the case with area. But let's concentrate on this piece. And let's try to do the first problem using this fact instead of doing it the long way. Let's go back to it. So remember the fact, okay? The perimeters of two similar figures are proportional with the sides. So another way we could have done example 1 is we could have made a proportion. We could have said 11 over 5 equals P over 10. We could have solved for P this way. We could have just cross multiply here. You get 5P equals 110. Divide both sides by 5. 5's cancel out. We get P equals 22. So you could use that fact to find the perimeter of the other figure. That works also. As opposed to doing it the other way where you just figure out what the sides are, and then just add them all up. This works nicely. Now, this is important though, right? This is not going to work for area. It will not work for area. You need to know that. This is not the case for area. For area, we have something else. So this is the area relationship of similar figures. And it says if two similar triangles or figures have a scale factor of A to B, then the ratio of their areas is A squared to B squared. And basically, I simplified it for you here with this proportion. And in this proportion, the left side represents the sides of figure A and figure B. And the right side of the proportion represents the areas of figure A and figure B. All right, so let's use this proportion to solve a problem. Example 2 says triangle RST is similar to triangle XYZ with RS equal to 3 inches and XY equal to 2 inches. If the area of triangle RST is 27 square inches, determine and state the area of triangle XYZ in square inches. So we got two triangles. RST is going to be bigger. You'll see why in a second. And we got XYZ. It says RS is 3, and then the corresponding side XY is 2. It's smaller, so that's how I knew this triangle has to be smaller than RST. We also know the area of RST is equal to 27. And we're being asked to find the area of the second figure. I'm going to call it area 2. We're asked to find area 2. Well, remember what I said in the beginning, right? You can't do 3 over 27 equals 2 over x. You can't do that because that only works for perimeter. You got to use a different proportion for area. You got to use this one here. So remember, in this proportion, the left side, the things being squared represents the sides. Sorry about that. And the parts not being squared represents the areas. So we're going to substitute. We're going to get 3 squared over 2 squared equals 27 over A2. Let's simplify it a little further. We're going to get 9 over 4 equals 27 over area 2. And let me extend my page here. We're almost done. 27 times 4 is 108. And then we get 9 times area 2, which will be 9 area 2. Divide both sides by 9. Trying to get area 2 by itself. Area 2 is 108 over 9, which is 12. So this area 2 is equal to 12. All right. I hope this helps. Take care.